So on this recording, we'll be doing chapter 1. I will be showing you guys how to do the conditions. So the first thing that you guys have to know is to sketch this, how to sketch this table. The binary, the decimal numbers right from 0 to 15. Must not write from 0 to 15. So that now when you convert, you don't have to struggle. So I'm going to sketch this quickly and then we can look at how to actually convert. So we have the binary, we have the decimal, and we also have the hexadecimal. So we have 0, 1, 2. So in binary you'll have this. So we have 0, 1, 1, 1. So we're going to have this. So this is for the first 4 digits. For the first 7. Then we also have the, so these are our binary and our decimal bits, and then I've got the hexadecimal. So we also have 0, 1, 2, 3, 4, 5, 6, 7. And then 8, 9, 10. Then this will become 1000, then 1001, 1010, 100, then 1110, then 111, and this one will be 15. So number 15, you must know that we're ending with this. So now you must also fill up this. So with the hexadecimal, our values will change from here, from 10. From 10, this will now become A. Then you'll have B, C, D, E, F. So we're ending at F, right? This is the hexadecimal. So let's try to also include the octal. Zero, 1, 2, 4, 5, 6, 7, And then from decimal to octal, when you reach 8, now this will now change to 10. And then you have 11, 12, 13, 14, 15, 16, 17. So the next one was going to be you were supposed to have, see, 11 is 13, 14, 15, 16. And the last one we must have, yeah, we must have 17, right? If we're ending there. If we're ending at number 16, here we're going to have 20. Here. So yeah, I'm going to leave this table for you guys to grab, right? Now let's do some conversions here. So we can convert from binary to decimal. Can convert from octal to decimal. You can convert from hexa decimal to decimal. You can also convert from decimal to binary. From decimal, you can convert again to octal. Just the opposite, right? So don't do these things in the same way. And we also can convert from, so let's divide this. We can also convert from binary to octal. Can also convert from binary to hexadecimal. Can also convert from, so I'm now losing that. We can also convert from octal to binary. Can also convert from octal to hexadecimal. And also convert from hexadecimal to binary. So you see that we have a lot of things to do. And then we can also convert from hexadecimal to octal. We can also convert from octal binary. We can also convert from hexadecimal to binary, and we can convert from decimal to binary. So this one, they usually like asking it as well. So let's do some examples here. From binary to decimal. So I'm starting with the simple stuff. The formula is like this. You're going to take your binary number times 2 to exponent I. Let me see if I can maybe simplify it better. So if you guys see something like this, just know that this is just part of the explanation of the book. 2n minus 1, 2n minus 2, 2, 2, 0, 2, 1. This is just how actually got to get this formula, right? Just the description of that formula. Where A is an element of zeros and ones. We know that we're talking about zeros and ones. So now let's do an example. I want us to actually do an example. We are converting from binary to decimal. From binary to decimal. So I'm gonna write an example now. One, if you are having, and also, okay, I'll write this formula after, and also, okay, or let me first write it. If you see this formula, don't be shocked. When you're converting from binary to decimal, so the decimal will be equal to the bit times 2 to exponent n plus times 2n minus 1 plus, so this will keep on decreasing. Let me write also the next one. Bn minus 2 to n minus 2 plus v1 times 2 to exponent 1. So at the end you'll have what? You'll have that. Now we know where, so this is b is a what? Is either 0 or 1. B is either 0 or 1. So now we're going to say example 1, convert this to decimal. So I'm going to simplify it. So this will be, you're going to multiply this one with 2 to exponent 0, to exponent 1, to exponent 2, to exponent 3. So that's the format. So meaning 1011 base 2 would be equal to 1 times 2 to exponent 3 times 2 to exponent 2 plus 1 times 2 to exponent 1 plus 1 times 2 to exponent 0. This will give us 11 base 10. So that's the answer. So now I want us to convert from decimal to binary. So this is the reverse. So we're going to take example 1. Provided you have got this decimal 25 base 10 as our decimal. So you're going to write division quotient remainder. So this will be 25 divided by 2, 12. Then this will be 12. The remainder will be 1. Since this will be 12 comma something, then this will be 12 divided by 2, 0. Then 6 divided by 2, 3, 0. 1 divided by 2, 0, remainder 1. Now, you're going to take this going up. So your final answer will be, so 25 base 10, it's equal to what in binary? 1101, 001 base of 2. And also do another example. And take 45 base 10. With the 5 over 2 would be 22, remainder 1. And then we check 22 divided by 2, 11, remainder 0. 5 remainder 1. 2 remainder 1. 1 remainder 0. 1 divided by 2, 0 remainder 1. So you're going to take this going up. So our final answer is just base of 2. So this is our binary V or byte. Then I want us to now convert from, no, let me, before I convert, let me first write the formulas so that this can be simple. From hexa to binary, I want to first, let me first show you the formula, some of the formulas, right? From hexadecimal to decimal. So the decimal value will be 16 to exponent I. We start from 0 up to n. Start from 0 up to n. So it means our I is 0, 1, 2, 3, and so on up to n. So the way we were doing, meaning if you are having 2f base 16, this is an hexadecimal. This will be 2 times 16 to exponent 1. Then this one is 15, right? In the table, our f is equal to 15 in decimals. As I said, you guys must know this table. Then you'll have 15 here. Then 15 times 16 to exponent 0. And this will be 2 is just for the 7 base of 10. So we managed to convert to decimal. Mm -hmm. And if we're converting from decimals to hexa, you're going to draw the table again. Write it here. Just say division quotient, and here the remain. So here you're going to write that value, whatever value that you are talking, we want to convert. If we want to convert for the 7, we're going to divide it by 16. Then here you write the value up to until. So that's how you convert from decimals to hexa. From decimal to hexadecimals. So some the other formulas that I've been shown you, let me see something here. Okay, I showed you this one, right? We're converting from hexa to decimal. Let me just copy this. So when we convert from when we're converting from I want to now do the one from octal to decimal. From octal to decimal, so your decimal value will be I from I equal to 0 to n. So the octal value times 10, you times 8 to exponent n. So don't be shocked also if you see your formula written like this on the slide. It's the same thing. The next, this means we're decreasing to the next v, you see now, 8 to exponent n minus 1 d1 times 8 to exponent 1. Yeah, so that's how we convert. So now I want us to do the conversion of 25 base 10 to binary. So you're going to divide, you get 12 in the one. I think I've already done this, but let me just do it again. Then the division. We've already done this, so now I want us to convert from binary decimal. They say convert decimal. So you're going to say 1 times 2 to exponent. We'll start here, right? So we'll start from 1 times 2 to exponent 0 plus 0 times 2 to exponent 1, 1 times 2 to exponent 2, 0 times 2 to exponent 3, 1 times 2 to exponent 4. So your answer will be, you'll get 21 base of 10. So that will be your final answer. So you guys can also go and convert this as an exercise. You're converting this to decimal. Now from octal to decimal, given this, convert to decimal. This will be 3 times 8 to exponent 2 plus 4 times 8 to exponent 1 plus 5 times 8 to exponent 0. Then you have this. Two two nine base of 10. So we have managed to convert to decimal. The hexagon decimal. 3a convert 3a base of 16 to decimal. Now also want us now to convert from decimal to hexadecimal. This will just be 3 times 10 to exponent, you times 16 to exponent 1 plus 10, because this is 10 times 10 to exponent times 16 to exponent 0. Get 3 times 16 is 48 plus 10, which is 58 base of 10. So from decimal to hexa, you just do 3 examples of this. then we'll be done. Let's say they say convert 26 base of 10 to hexadecimal. So you're going to write division quotient remainder. 26 divided by 16, you'll get 1 remainder 10, and then 1. Now we take 1, we divide by 16, you'll get 0 remainder 1. So our final answer is this. So we know that this will become, we know that 10 is equal to a, so this will become 1a base of 16. So I've managed to convert to hexadecimal from decimal, which was 26 base of 10. Now, if they say convert 47 base of 10 to hexadecimal, that will be 47 over 16, which is 2, remainder 15. 2 divided by 16, 0, remainder 2. And from your table, 15 is equal to f, which is what you must know. So now this will become 2f base of 16. So managed to convert from 47 base 10 decimal to x decimal. Now, if they say convert, let me just do one more, from decimal to octal. From decimal to octal, suppose you are given 25 base 10, they want you to convert to octal. So you will say 25 divided by 8. So divide by 8. Then you'll get what? You'll get 31 base of 8. So this is when you're converting to octal. Now I want us to do the ones whereby you'll have to group. The binary numbers. So from binary to, let's say you're converting from binary to octal. So we don't know what this is equal to. So you're going to group this into 3. So you're going to group the binary digits into 3. So this on the table 0101. Let's go and check 0101 and use this one. 0101. It's equal to 5. So that was there. So in this case, you know that this is 5 and this is 5. Right. So the answer to this will just be 55 base of 8. Then if they say convert 10111, so here we're going to take the first one, is to be 1011011. So I want these numbers to be 5, you see. So when you group into 3, this one will be 2, so you'll have to put a 0 there. So this guy is equal to 3 and this one is equal to 3. So the answer is just 33 base 8. And then from binary to hexa. So here you group into 4. So this will be equal to A. This will be equal to F. You see. So now your final answer will just be 10 base of 2. It will be EF base of 60. So this is your answer in hexadecimal. So I'm gonna stop. Let's see.